All right, here are the exercises from 4.4a through C. 4.4a. Use a diagram to name the included angle between the given pair of sides. So the included angle has to be the one that is directly in between them. So we have GH and HI. It's like this. The angle is right there, which would be H. HI and IG. Angle I. How else you can do this? You look at what letter repeats. So this one, there's a G here and a G here, so it's angle G. This one's GI and IJ, it's angle I. This one's JG and IG, it's angle G. And this one's IJ and GJ, so it's J. It works every single time. Look, IJ, GJ, they come together there. That's the included angle. It's included because it's in between the two of them. All right, decide whether enough information is given to prove that the triangles are congruent using side, angle, side. Okay, here we have a side congruent to this side. Let's jump to the sides. Another side congruent to this side. And we have the angle in between them, or the included angle, congruent. Right? But it's saying triangle LMN and triangle NOP. So LMN and NOP is going to be side, angle, side. So your answer would have just been yes, I guess. Yes. What about ABD and CBD? So if we have a right angle here, then you know this is a right angle. Right? Then you have AD. DB is going to be congruent to itself, right? So we have side, angle, side. But over here we have side, side, angle. See, there's no angle in between. If it would have been this angle, then yeah, it would have worked. But it's not. So this is ASS. If you believe that that works, then so be it. Angle side side does not work. So that would be no. Just make sure that your angle is included if you're using side angle side. Make sure it's the one in between them. All right, DEG and FGE. So this is congruent to itself. So now follow it. DE is one line, FG is one line. Then you have the angle and two lines. Angle and two lines. So that would be yes. RST and VUT. So here we have a side and a side, but the angle is not in between the sides. It's out here. So this would be no. In order to use side angle side, it's got to be the angle that's in between the sides. So it would have to be this angle in here and this angle over here. But it's not. It's the one out here. So it's no good. And this is the one that's going to be on your test. Write that down. 4.4, practice A, number 10. Boom. Dropping knowledge for you. Number 11. Decide whether there's enough information to prove that triangles are congruent using hypotenuse leg. So hypotenuse leg says that the angle or the side that's opposite the right angle has to be congruent. In this case, the side opposite the right angle is HJ, and it's HJ here. HJ is congruent to itself by reflexive property. So we have a 90-degree angle and a 90-degree angle. We have this leg congruent to this leg, and their hypotenuses are congruent. So that would be yes. Look at number 12. We have the leg congruent and this congruent, but this is not a right angle, and this is not a right angle. So that would be no. State the third incongruence that must be given to prove that triangle ABC equals triangle DEF using the given postulate or theorem. So we're using sine angle side. We start out with angle B congruent to angle E, BC congruent to EF, right? So now we have angle side. We need this side that comes before it. So you're going to need AB congruent to ED. Number 14, we're going to use side, side, side. So we have AB and DE, BC and EF. And so you need AC and DF. Number 15, AC is congruent to DF. Angle A is a right angle. And angle A is congruent to angle D. Use hypotenuse leg. We know AC and DF. Those are right angles. So all we need is the hypotenuse, BC congruent to EF. That's it. Number 16, suppose you have two skateboard ramps. What information do you need to know to prove that the triangular ramps are congruent using side angle side? So if we need side angle side, prove that these two triangles are congruent. I'm going to draw them, they're not going to be congruent, so kind of ruins it, but you'll understand the point. You need side angle side. You could use this, this, and this. Congruent to this, this, and this. Oops, should only be one. Alright? The other way, you have a ton of possibilities for this. It could also be side, angle, side, and side, angle, side. So you can measure the horizontal distance and then the distance of the ramp. Now for hypotenuse leg, you assume that your height of the ramp is going to be straight up and down. So you would need that being a 90. And then you would need to know this height and the hypotenuse is equal. Or you still need hypotenuse, but you could also use this leg. Either one works. 4.4b. Use the diagram to name the included angle between the given pair. Zoom this in. AB and BC, it's the one that repeats. It's going to be angle B. Number 2, BC and CD, angle C. AB and BD, B, ED and DA, D, DA and AB is A, CD, DB, D. If you miss those ones, I don't know how to help. I'm giving up. Alright, decide whether enough information is given to prove that the triangles are congruent using side, angle, side. Here we have an angle, a side, and then we're going to have this side congruent to itself because it is reflexive. So we got ASS, enough said, no. DKA, we have side, an angle, and a side, and that is congruent to a side, an angle, and a side. So that would be yes. Number 9, we got this angle is going to be congruent to this angle, but we don't know anything about, well, we know that this is congruent to itself. Don't know anything about this from this. So this would be no. Decide whether enough information is given to prove that the triangles are congruent. If there's enough information, state the congruence postulate or theorem you would use. So we have side, angle, side, and then it's congruent to side, angle, side. I've said SAS. This one we have a right angle. So as soon as I see this right angle, that's not necessarily always going to be hypotenuse leg, but that's going to jump into my head that I need to look to see if the hypotenuse is congruent. Hypotenuses are congruent, and then we have this leg inside of here congruent to itself. So it's hypotenuse leg, HL. Okay, this one. We have this angle congruent to itself, right? So we have side and an angle to the side. So these two are congruent to each other. Now look up here, we just have the angle. No, we don't. We know that these sides are going to be congruent to themselves, but it doesn't mean they're going to match up with this, with these two sides down here. For instance, I could make, and I'm drawing this, so it's obviously probably not going to be right or perfect, you know what I mean? I can make this like that, right? And say this angle is congruent like that. But then I could also have another angle that is much larger, or that's exactly the same on the bottom, but my sides could run up like this. Like I said, not going to be a good drawing, but you get the point, I think. My sides could extend past this length. Like that. So basically we don't know. So that would be no. State the third congruence that must be given to prove that triangle JRM is congruent to triangle DFB. JR is congruent to DF. JM congruent to DB. We're using side, 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 so I need this third side congruent to this third side. So I need RM congruent to FB. JR and DF, JM and DB. We need side, angle, side. We have side and side. We need the angle in between them. So you need angle J congruent to angle D. Then number 15, we have RM congruent to FB. J is a right angle, and J is congruent to D, so D has to be a right angle. Then we need legs congruent to each other. So we have hypotenuse, we need the leg. So we could do JM is congruent to DB, or we could have JR congruent to FD. And that's fine too. Well, it should technically be DF. Right? Next page. Moving right along. B is the midpoint of AE. How do we know that? Given. Then, if that's the midpoint, what's that tell you about what's happening here? If it's the middle point of this segment, it tells you that this is congruent to that. So AB is congruent to BE. Then midpoint B is the midpoint of CD. So it tells me that is also given. That tells me that DB is congruent to CB by definition of midpoint. Then ABD, this angle, and CBE or EBC are congruent. Reason for that is vertical angles. Vertical angles are always congruent. Now if you look at this, I have a side, an angle, and a side. So I know that those two are congruent by side, angle, side. This side congruent to this one, angle, side. And you're done. 4.4b, number 16, is a great test question for a proof. Maybe all your proofs will come from this. Oh no. 4.4b, number 16. I like that one. Those of you who watch those videos are going to get some help here. Number 17, complete the proof. AB is parallel to CD. Sorry. That's given to you. Then how do you know that ABC is congruent to DCB? Those are alternate interior angles. AIA. Then how do you know AB is congruent to CD? That is given to you. And how do you know CB is congruent to itself? Reflexive. And triangle ABC congruent to DCB. I got side, I got angle, I got side. SAS. That's it. On to practice C. Couldn't see the little recording thing, and it was scaring me that I just did all that and it wasn't recording. That would be bad. Real bad. Alright. Decide whether enough information is given to prove that the triangles are congruent. If there's enough information, state the congruence postulate or theorem you would use. So, if I look at this one, I got this congruent to this. The angles are congruent. I don't know anything about these being parallel. I don't know anything about the other sides. So I have one side and an angle across from it. So it's just no. Number 2 is just an ugly picture all scrambled up. And that's the point. They're trying to confuse you. But if you look at it, highlight your triangles. I got GHI, and I got JKL. Right? So this one's got 2 and 2. So let's see if JK and GH both have 2 and 2. 2 and 2. So far so good. Now I'll try HI. Don't know anything about HI. Or LK. Well, let's try the other side. GI has 1 and 1. LJ has 1 and 1. So those are congruent. They both have the same distance. And we have this 90-degree angle in here. So I have a hypotenuse congruent to a hypotenuse, and a leg congruent to a leg. So it works with HL. MNO. MN and PQ both got 2 stripes. Right? So MN is congruent to PQ, so I got a side. Then here I have QR is congruent to NO, because those both got 1 and 1 and 1 and 1. So I have another side. And then if I'm looking at this triangle, I have an angle. I have a side-side angle. Not enough. No. This one, STX, we got this, this, and this. Now this one is a little tricky, because you see that right angle? That goes inside. That's not why it's tricky. But you automatically assume this is hypotenuse leg. It is not. This is the hypotenuse out here. We don't know anything about it. So it's side, angle, side. SAS. Number 5. Given BC is congruent to ED, this is congruent to this. AC is congruent to FD. This thing is congruent to this thing. Make side angle side work. Just look at your triangles. I got a side. I got another side. I need the angle in between. So I need angle C congruent to I got a side. I got another side. I need the angle in between. So angle C has got to be congruent to angle D. All right, AB is congruent to FE. AC is congruent to FD. So I need to know is BC is congruent to ED. That's good. Number 7, BC is congruent to ED. Angle B is a right angle. And B is congruent to E. So that's a right angle. And I need to use HL. So I need to know that AC, or the hypotenuse out here, is right angle. It's going to be the opposite of the right angle, or the side of the triangle that the angle doesn't touch. Right? So when you're talking about opposite sides, if you can't tell which side is opposite, there's the right angle. Which side doesn't it touch? Touches AB, touches BC, doesn't touch AC. AC has to be congruent to DF. We could do the same thing with that other triangle. We said like this, or I think it was EF. That was ED. And this and that both form the right angle. DF is the side that does not touch the right angle. This looks like one of those stupid ones. Suppose P is the midpoint of OQ in triangle OQS. If SP is perpendicular to OQ, explain why triangle SP is congruent to SPQ. Alright, so let's draw this. We got OQ. Let's call that O. That's Q. This is going to be S. Right? Now P is the midpoint in between them. And it says SP is perpendicular to OQ. So it makes a right angle there and a right angle there. Explain why triangle SPO is congruent to triangle SPQ. Since this is the midpoint, it breaks this side in half perfect. So this OP is congruent to PQ. Then SP is congruent to SP in both triangles. So we have side, angle, side. That's it. Complete the proof. QS is congruent to PR that is given. PS is perpendicular to RS, and QR is perpendicular to RS. Angle S and angle R are right angles. That is definition of a right angle. Then this PS is perpendicular to RS. That means that is a right angle, and QR is perpendicular to RS. That means that is a right angle. So then we know that two triangles are right triangles in here. So you have this right angle, then the third side of that would be there, right? And then you have this right angle. It's terrible. This right angle, like that. And the third side of it would be SQ, like that. Okay, so I know that SRP, triangle SRP, is a right triangle. We can reword this better. SRP and RP and RSQ are right. Triangles. And RS is congruent to SR. It's because it's exactly the same. So that's reflexive. And it already told us that QS is congruent to RP. So this is congruent to this. And so we have hypotenuse leg. complete the proof. OM is perpendicular to LN. And ML is congruent to MN. So if two angles are perpendicular and they form 4 right angles. So that tells you that angle OML and angle OMN are right angles. Then that tells you that angle OML is congruent to angle OMN. This gives a right angle congruence theorem. All right angles are congruent. ML is congruent to MN. That's given to you. OM is congruent to itself. That's reflexive. Now I have a side, an angle, and a side. SAS. Done. All right, so that's 4.5 A3C, or 4.4 A3C. Did it in better time this time.